Before watching this video, make sure you have a good understanding of exponents and least common multiple. If not, it is recommended that you watch those videos again. In this video, we will learn how to find the least common multiple if the numbers are written using exponents. Let's take a look at some of the exponent rules to refresh our memory. I have a few of the exponent rules written here on the board behind me. So the first one we're going to look at is when we have a times b to the n power. We need to remember that it is equal to a to the n power times b to the n power. So using numbers for an example of this rule, if I have 2 times 3 squared raised to the second power, it is equal to 2 squared times 3 squared. With this second exponent rule, if I have a number to the m power times that same number to the nth power, then it equals a to the m plus n power. So I simply add the two exponents together if my bases, my numbers a, are the same and I'm multiplying. So here's a case with numbers. If I have 2 squared times 2 cubed, this only works if these two numbers are the same. So 2 squared times 2 cubed, it is equal to 2 to the 2 plus 3, or 5th power. If I'm multiplying, I add my exponents. And in this third rule here, if I have a number and it's raised to the m power and then that's raised to the n power, it's the same as that number to the m times n power. So for an example of seeing this written with numbers, if I have 2 squared to the third power, it is equal to 2 to the 2 times 3 power, or 2 to the 6th power. So I simply multiply these exponents. Finding the least common multiple of exponents works mostly the same as with the non-exponent numbers. You will remember that we find the least common multiple by performing the prime factorization of each number. The difference here is that the numbers are expressed using exponents. Our first step is going to be looking at the numbers and finding numbers which are not written using prime numbers. So let's look at an example and we'll go through the 3 steps of solving a problem, finding the least common multiple with numbers that are written using exponents. So in this list we see that 2 and 7 are prime numbers, but that 6 is not a prime number. So my first step, step 1, is simply identifying that 6 is not a prime number. My second step is going to be to perform the prime factorization of 6 so that I can put it in terms of prime numbers. So I know that 6 equals 2 times 3, and that's the prime factorization then of 6, a very simple one, because I can break it down right away into 2 prime numbers, 2 and 3. So 6 is equal to 2 times 3. Well, we have 6 cubed here. So I need to do, let's see, 6 cubed. I can rewrite this as 2 times 3 cubed. So I simply have replaced the 6 with its prime factorization of 2 times 3. And using the exponent rules that we looked at before, we know that 2 times 3 cubed is equal to 2 cubed times 3 cubed. So the power of 3 goes here to the 2 and to the 3. I can also write this without having this little x for the multiplication in between. So you will see this also written as 2 cubed, 3 cubed. Sometimes just like this, 2 cubed, 3 cubed, sometimes with an X in the middle, and sometimes with a little dot in the middle to represent that this is 2 cubed times 3 cubed. When they're put together like that, we don't need any symbol in between. So now what we're going to do is we're going to rewrite this 6 cubed as 2 cubed, 3 cubed. So we really are looking for the least common multiple of 2 cubed, 3 cubed, or 2 to the third power times 3 to the third power, 2 to the fourth power, and 7 to the second power to the power of 2. So our step 3 now is to find the least common multiple. So I'll put LCM here to remind us what operation we're performing or what calculation we're looking at. We are finding the least common multiple of these 3 numbers. So what I want to do is I want to look at each prime number, and I want to pick the prime number with the highest power used in any of the numbers. So right now I can see here that I have 3 prime numbers that I'm going to be working with in this problem: 2, 3, and 7. So first I'm going to begin by writing my 2, my 3, and my 7. Those are my 3 prime numbers. Now I need to decide which power each of those prime numbers will be given. So I go back and I pick the prime number with the highest power used in any of the numbers. So if I'm looking at the 2's, I can see that the highest power in the given to the 2's is 4. And so I'm going to put this power of 4 for the 2. So it's the highest number. I don't want to choose this one because it's only a 3. I'm choosing this one because it's bigger. Now, in this situation, I really only have one choice for my 3, so 3 to the third power, and I only have one choice for my 7, 7 to the second power. But if there were other sets of numbers using the prime number 3 or 7, and they were raised to different powers, I would always choose the one with the greatest power. So, at this point then, I actually can put a square around my answer, because when my numbers are given using exponents, I am most of the time required to give my answer then using exponents, unless you're asked to go ahead and work out what this number really is. So it would be 2 times 2 times 2 times 2 times 3 times 3 times 3 times 7 times 7, and it actually equals 21,168. But I'm just going to leave my answer here in terms of the base of the prime numbers raised to the exponents, and leave my answer in exponent form. So the least common multiple of 6 cubed, 2 to the fourth power, and 7 squared is 2 to the fourth power, 3 to the third power, and 7 to the power of 2. Let's take a look at a more complex problem, finding the least common multiple when our numbers are written in exponents. So our problem says that we are to find, or we're asked for, what is the least common multiple of these 3 numbers. So my first one is 2 to the first power, or 2 to the 1, 4 to the second power, 5 to the 1, 9 to the 1. So that's the same as if we were multiplying together 2 times 4 times 4 times 5 times 9. That's one number. And then our second number is 2 to the first power, 4 to the first power, 5 to the 1 power, 6 to the 1 power, 9 to the 1 power. That's the same as if we were to be multiplying together 2 times 4 times 5 times 6 times 9. And then our third number that is in this set that we're trying to find the least common multiple of, our third number has a little more exponents here with 4 squared, 5 squared, 9 to the 1 power. So this number would be 4 times 4 times 5 times 5 times 9 if we were to work any of those out. But we are going to leave them all in exponent form. But first, our first step is to find the numbers that we have here that are not prime numbers and put them into their prime factorization. So with our first number of 2 to the first power, 4 squared, 5 to the first power, 9 to the first power, I can see right away that I have two numbers here that are not primes. I have 4 and 9. And so I need to rewrite my number as 4 equaling 2 times 2 and 9 equaling 3 times 3, so that those are written in their prime factorization. And then, using my different exponent rules, I go from 2 times 2 to 2 squared and 3 times 3 replaced by 3 squared. And then one step further then, I can write my 2 to the 1 power. 2 squared to the squared is 2 to the 4th power. 5 to the 1st power. And then 3 squared to the 1 power is simply 3 squared. I can combine my like bases, my two 2's, by adding the exponents together. And so this number then becomes 2 to the 1st power times 2 to the 4th power becomes 2 to the 5th power, and then I've got my 3 squared and my 5 to the 1 power. So this right here is the number that is the same as this, except that it has been written all in prime factorization, still in exponent form. My second number I also want to simplify like I did my first and turn it into its prime factorization. So my second number is the one that has all the powers raised just to the 1 power. But that's going to change when we combine them. So I've got 2 times 4 times 5 times 6 times 9, all numbers to the 1st power. But first I have to identify which ones are not prime numbers. And so I can see right away 2 is a prime number, 4 is not. 5 is prime, 6 and 9 are not. So I need to rewrite my 4 as 2 times 2. I need to rewrite my 6 as 2 times 3 and rewrite the 9 as 3 times 3 so that they're all in their prime factorization. They're still all raised to the 1st power at this point, but now I can replace 2 times 2 and 3 times 3 with 2 squared and 3 squared. And so I have 2 to the 1 power. 2 squared to the 1 power is just the same as 2 squared. And then 5 to the 1st power. And then 2 to the 1st power times 3 to the 1st power. I just pull those out from the parentheses and make it 2 to the 1, 3 to the 1. And then this last one that I have 3 squared to the 1 power, I simply have 3 squared then, because I multiply 2 times 1, which equals 2. So now I've got a long string of prime numbers with their exponents. 2 to the 1 power, 2 to the 2 power, 5 to the 1 power, 2 to the power of 1, 3 to the power of 1, and 3 to the power of 2. Now, any of these prime numbers that appear more than once, I can simply add their exponents together. So I have a 2, 2, and 2 with exponents 1, 2, and 1. That becomes 2 to the 4th power. I have a 3 to the 1st power, or the power 1, and I have a 3 to the power 2, which then those two exponents add together and gives me 3 to the power 3. And the only 5 I have is 5 to the power 1. So this 2 to the 4th power, 3 to the 3rd power, and 5 to the 1 power is my simplification in prime factorization of this number right here. 2 times 4 times 5 times 6 times 9. And then I'm going to do it one more time here with my last number. 4 squared, 5 squared, 9 to the 1 power. So 4 squared, 5 squared, and 9. I see in this case, I always want to identify which ones are not prime numbers first before I get to work, and I can see that 4 and 9 are not prime numbers. So 4 and 9 are going to be replaced by their prime factorization. 4 is equal to 2 times 2, and then I still have my 5 squared, and 9 is equal to 3 times 3. So I've got 2 squared to the second power, or raised to the power 2, 5 to the power 2, and then 3 squared to the power 1. This simplifies then down to 2 to the fourth power, 5 squared, 3 squared. And so here I just rearranged it so that it would be in order of the smaller primes first. I want them all to be 2's first, 3's next, and 5's last. So now that I have each of my numbers put into their prime factorization, now I can get to work on finding the least common multiple, which is actually going to be quite simple given that I have everything in order. So all I need to do to find the prime factorization at this point is, let's draw a big box around it so we know we're working on the final step of our problem. We want to take our primes 2, 3, and 5. So in this case, the only 3 prime numbers that we are working with are 2, 3, and 5. And now all I need to do is find the greatest power given to the 2 in any of the 3 problems, or any of the 3 numbers, the greatest power that 3 has in any of the 3 numbers, and the greatest power that 5 has in any of the 3 numbers. So when I look starting with my 2, I see I've got a power 5, a power 4, and a power 4. So I'm going to choose the power 5 for my 2 prime number because that's the largest of the powers. For my prime number 3, I have a power 2, a power 3, and a power 2. So I'm going to choose my power 3, which is the largest of the powers for the 3. And lastly, for my 5, I have power 1, and power 2. So the largest of those is going to be power 2. And I'm simply going to leave my answer in that form of exponents. I'm not going to multiply it all out and find the great big number that it is equivalent to. But I have just found the answer to what is the least common multiple of this number, and this number. The answer to that is 2 to the power 5 times 3 to the power 3 times 5 to the power 2.